Assalamualaikum. Good day to our beloved friends and honorable panelists. My name is Morteza Yurki Kwanda, and I would like to thank Puonglo for letting me have the chance to present my proposal, which the title is Development of Noise Isolating Ear Insert for Cartilage Conduction Hearing Protection Device. The presentation will be divided into three chapters, which the first chapter will be Introduction, second one Literature Review, and the third one is Methodology. Introduction. The background for the study is that workplace possess numerous hazards. One of the hazards this proposal focus on is noise exposure. The second one is that prolonged noise exposure could lead workers to a faster process of irreversible hearing loss, although hearing tends to decline with natural aging process. The third one is that noise exposure related occupational disease took more than half of the recorded occupational related cases. And the last one is that worker tends to not use hearing protection device as it seems to interfere with communication. From the background study above, I've gathered some problem statement, which is high exposure of high noise is the major common cause for work-related disease. And the second one is that conventional hearing protection device cause discomfort to the user. And I have set objective for the study, which is to design and develop a pair of noise isolating ear insert for use in cartilage conduction hearing protection device. And the scope for this study is that to design the noise isolating ear insert, fabricate the noise isolating ear insert, testing the noise isolating ear insert in simulated noisy industrial working environment, and the last one is to performance evaluation and benchmarking with conventional hearing protection device. Literature review. From journals I have gathered online, this is the remarks I could get. The first one from Manifasa Gambi, Khalida, Tiagarajan B, Yusuf B, Jamaluddin B, which the title is that Empowering Occupational Health Doctor Through Occupational Safety and Health Noise Exposure Regulation 2019, published in 2019, which the remark is that in Malaysia, occupational noise-related hearing disorder are responsible for more than half of the total case from occupational disease. Second one from Wandi N, Nurzia Ismail, and Ruslan, which the title is that Occupational Noise Exposure and Its Impact on Palm Oil Mill Worker Health, published in 2020. From this, I get the noise level at workplace. And the third one from Jose H, Nishimurati, Shimugura R, and Hitarati, which the title is Cartilage Conduction as the Third Pathway for Sound Transmission, published in 2019. The remark is that slight vibration to the ear cartilage could create an audible sound. And the fourth one from Sinha, Sohaman Irani, Urfas, Mankhaya, Vinaya, and Bamla Saad, which the title is that Log 8, an ultra-low cost hearing aid for age-related hearing loss, published in 2020. The remark is that some pressure level at ear canal could be measured by through simulation of human ear with grass by camera. The fifth one from Bungrad, Walden, Patak, Theodorov, Gris, and Grain, which the title is Development and Validation of the Speech Reception in Noise Test Sprint, published in 2017, which the remark is speech reception in noise test was one of the tests you use to assess hearing capability. This test will be used to determine speech perception of user while using the ear insert. And the sixth one is from Kwasi, C. Shenji, and Huang S., which the title is Study and Analysis of Process Parameter for Silicon Rubber Mold, published in 2018. Which the remark is that rubber silicon mold provides the capability to fabricate the ear insert prototype. And the last one from Koloff O, Burke T, and Erickson V, which the title is A Comparison Study of Foams versus Custom Silicon Earplugs Used as Part of an Intelligent Electronic Hearing Protection Device, published in 2020 and 2010, with the remark comparison between foam and silicon earplug noise reducing capability. And this is the methodology. This is the research flowchart of the study. Started with topic selection, which I choose this topic. After that, I identify the problem background from the topic and the objective of scope. An objective and scope of the study will be continued on. So that doing literature review. After done doing all of this, I design the model for ear insert. Later on will be fabricated and tested, and the data will be collected to be compared, and the result will be used for report writing, and the last one is to present the result of the research. The functional decomposition of this ear insert should be able to attenuate sound by complying with AUXIA regulation. The second one is to able to integrate with cartilage hearing aid prototype through the speech perception and noise test. And the last one is comfort of the user. This is the morphological chart for the ear insert. How to connect to the transducer. The idea one is to use adhesive, and the idea two is to use housing. The additional feature, idea one cone-like shape at the back to reflect the sound. The material, idea one is from foam, and idea two from silicone. The consideration for this ear insert started from noise level at workplace. Like as the example above, uses welding, the average noise level is 98.4, grinding 99.7, screw gun 97.7, or in workstation and water treatment like 94.9. And the noise isolating ear insert will insulate ear by blocking the incoming sound. The ear insert itself will be inserted into the ear canal, and the cartilage sound conduction will be done by vibrating the ear cartilage. This is the ear cartilage as shown in the picture. Ear cartilage. This is the reference for conventional hearing protection device, the noise reducing silicone ear plug model BM835. And this is the electronic hearing protection device, which use the transducer model RC-BC04. And this is the proposed design. Model number 1. Design model number 2. Design model number 3. Design model number 4. And this is the evaluation for final design. This is the evaluation matrix, which the criteria is able to integrate with the transducer, able to attenuate sound, its appearance, weight, comfort, and cost. The fabrication itself starts with designing through computer-aided software, which is this one is using SolidWorks. After that, the design will be printed with a 3D printer to make a master model, and the master model itself will be used for rubber silicone mold casting. The master model will be prepared and be inserted to a mold box. The mold box itself will be sprayed with some layer to ease the process of separating, and rubber silicone mix will be mixed, and it will be poured to the mold box. After it poured, it will be weighted for the molding and parting the mold and taking out the master model. There will be a cavity for it, and the cavity itself will be used to replicate the model by inserting the desired material. And this is the method of testing. The first one is speech reception in noise test. This one is to assess the hearing perception of the user. And this is the schematic for the test itself. Two speakers emitting noisy sound at 75 decibels will simulate the noisy industrial working environment placed at 3 meters and 2 meters, while the user with hearing aid will be faced with a speaker to emit speech and words, and the user itself should be able to mengulang kata dengan sama persis, and the words itself will be taken from everyday words. And the second one is human ear simulation by grass, using grass by camera. This is the technology used to simulate the ear canal. Sound level pressure instrument is inserted in the ear canal of the robot, and the ear canal will be placed with the hearing aid prototype. And the speaker will emit sound ranging from 1550 hertz to 10 kilohertz. And the sound level pressure at the ear canal will be measured by the computer, and the data itself will be collected. This is the Gantt chart for FYP2, and this is the Gantt chart for FYP1. And thank you.